Well, hello guys, Mr. G here with another question from 2016 June examination that was done at the Free State and Northern Cape province. This time we're going to be answering question 7. Okay, but before we start, please don't forget to subscribe for the channel so you can get all the notifications as well as the worksheets and videos I post on a regular basis. My voice is a little bit not well, I'm a little bit fluish, but we're going to do the video anyway. Now, question 7 says a small metal sphere X on isolated stand carrying a charge of positive 2 nanocoulombs. What is electric field? And what is electric field? Electric field is a region in a space in which a charge experiences a force. Very easy, guys. Let's go to question 7.1.2. Draw an electric field pattern associated with X. Now, you need to know and notice that the charge is a positive charge. Okay, so we're going to draw the pattern on this side here. We having a positive charge here. This is the charge positive, and then all the lines are going to go straight out of the charge. All this line must be straight, guys. I've been seeing very funny curve lines which is not correct. All those lines are coming from the charge. They must touch the charge straight, and this is how to draw that electric field pattern around a charge. If there were two charges interacting, then the pattern would look different. I've done videos like that. You can go and watch those videos, but this is how the lines look like. Alright, don't draw many lines. I don't recommend to draw a lot of lines. The more lines you draw, the more mistakes you can make. And guys, this is question 7.1.2. 7.1.3, calculate the magnitude of the electric field at any point 1 meter from the center X. So all they want to know is how strong is the electric field when it is allocated, or electric field at 1 meter from the charge. So let's quickly go to the formulas. Well, electric field at the point, this formula here is the definition for the electric field at the point. But this formula here is the one we are going to use to calculate the electric field at a point. Okay, now here we're going to write the data. The first thing we have is that the charge is positive 2 nanocoulombs. You cannot work in nanocoulombs, so we are going to convert it to coulombs, and this one is going to be 2 times 10 to the minus 9 coulombs. The second data we have is the distance, which is 1 meter, and the third data we have is K, which is given to us in a table. I'm going to show you the table. Here is the table, guys. Here is Coulomb's constant. This is the constant you are going to use for this topic there. So all you have to do is to come here and make sure you write it exactly the same without mistake. It's right one of the last pages. You can see we are almost there. So this one is 9 times 10 to the 9. I'm not going to write the unit for the data here right now. Now the formula is E, or electric field at the point, equal to K multiplied by the charge divided by the distance squared. Quite simple. So we are going to substitute, and that will be the end of this question. When you calculate this one, you get that the answer is 18 Newton per Coulomb, but no direction, because this one is a vector quantity, guys, but they asking you for the magnitude in the question. As you can see here, calculate the magnitude, and therefore if they say magnitude, no direction. Okay, question 7.1, identical sphere Y, and we already spoke about this one in previous videos. Identical sphere means same shape, it doesn't mean same charge and everything, which carries a charge of negative 7 nanocoulombs, is used to touch sphere X. The two spheres are afterwards placed 2 meters apart as shown below. In which directions did the electrons flow while X and Y were in contact? Write down X to Y or Y to X. Well, when they were in contact, we had two spheres, with one of them was a negative 7 nanocoulombs, as you can see it here on this side, and the other one was a positive 2 nanocoulombs. So now the electrons are always going to move from the more negative charge to the more positive. So the electrons were moving from this minus 7 nanocoulomb, which is Y, to x. So they move from y to x. This one is the correct answer for that question there. Calculate the charge on x after separation. So now this question, 7.2.2, calculate the charge on x after separation. Now, this is conservation of charge. So the charge must stay constant from the beginning during this process. Now, what we are going to do is, we are going to calculate, this one is question 7.2.2. We are going to calculate the new charge, Q new. And this one was done in previous grade. Is the addition of Qx plus Qy divided by 2. And for this calculation, you do not have to convert, right? You don't have to convert, but the signs must be added here. So it is 2 plus minus 7 divided by 2. So the Q new is going to be equal to negative 2,5 nanocoulomb. It means that each sphere will be negative 2,5 nanocoulomb after separation. Very simple. This question 7.2.2. Question 7.2.3, state Coulomb's law in words. And already we spoke about this one many times in another videos. So you can go and try and watch the videos. Let's go to Coulomb's law. And this law states the electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. It's very, very simple. It's really, really simple. Let's go to question 7.2.4. Calculate the electrostatic force that is exerted on X due to the presence of Y. So the electrostatic force, guys, we go into the formulas all the way down. I'm going to show you here. You go to the electrostatic or electrostatic here. It is. Here is the law. Here is Coulomb's law and is the formula you are going to use. Write this one there. Please don't memorize. You can memorize formulas, but make sure you go there and you take it exactly as it is in the formulas. Even if you memorize, go down there. Guys, I think we have enough space here. This is question 7.2.4. So we write in the formula here. The electrostatic force is equal to K multiplied by Q1, Q2 divided by the distance squared. All you need to notice is that after separation, each of them will have a charge of negative 2 nanocoulombs. So you have to convert charge A, which is equal to charge B. No, A and B is X and Y, sorry. Charge X, which is equal to charge Y, is equal to minus 2,5 nanocoulombs is equal to 2,5 nanocoulomb times 10 to the minus 9 coulomb negative. But remember, in these formulas, neither in this one or this one, you substitute the minus. So everything in this formula is positive. Remember, K is there, so I'm going to substitute everything here. And then, guys, the answer will be 1,41 times 10 to the minus 8 Newton. Now, the question here asks for the electrostatic force, X due to presence of Y. So what is Y doing to X? They both are negative, so they be repelling. So Y is pushing X to the left. So you have to give direction here, and it will be to the left. And this is the end of the question and the end of this video. So I hope it helped. This is question on electrostatic. We only have 2 more questions to answer for this question paper, which is question 8 we're going to solve next time. It's here is electric circuit, and then question 1, which is a multiple choice I left for last. But thank you for watching. Subscribe for the channel if you didn't yet, and then I'll see you next time. Mr. G here.